In this lecture, we're going to explore the use of graphical user interfaces, or GUIs, and we're going to use JavaFX to implement GUIs in Java using NetBeans. Hi students, this is your professor Dr. Mink, and welcome to part 2 of the video lecture for chapter 6 from Java Foundations Graphical User Interfaces. Let's get started. Quick review of what we just saw. Okay, the purpose of radio buttons is to establish a set of mutually exclusive options. Only one can be selected, and when one is selected, every other member of the group, in this case the toggle group, are deselected. Set toggle group method is invoked to specify which toggle group a button belongs to. When you add a radio button to a toggle group, if it was already a member of a different toggle group, it is removed from that toggle group and added to the new toggle group. It can only belong to one toggle group at a time. The isSelected method returns true or false, true if the button is currently on, false if it's off. Next up, color and date pickers. A color picker is a control that allows, and you've seen this before, unless you've never used a Windows-based application. It's a control that allows the user to select a color from a palette or some other model, and a date picker allows the user to select a calendar date from a pop-up calendar. Both appear as a single field and use what's called drop-down panes for the selection. Here we're going to take a look at date picker and color picker, and you'll see we've imported those JavaFX libraries. So here we have a simple JavaFX application called Picker Demo. New text object, reference variable named message, date picker, object reference variable called date picker, color picker, object reference variable, color picker. So we assign a new date picker object to the object reference variable named date picker, and we pass local date.now, and we'll get to that in a second. And here is the event handler called to process date choice. So the new date picker object needs a date, and that is called by local date.now. Local date is also a library here. That was imported here into this application. So new color picker object, we're calling it color picker, and we're setting its color to black, and then we're calling the event handler, and then we've got a new text object named message, and its original text is the string happy concatenated with local date.now.get day of the week. Day of the week is going to get the local date and calculate the day of the week that falls on, and it will return a string Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And we're setting the font of the message to Helvetica bold, and the posture is going to be regular 24. So then we're going to add the date picker and the color picker to a horizontal display pane named pickers. Horizontal spacing between those two will be 15, and they'll be centered. Then we're going to declare a new VBox option called root, object called root. Set the style spacing, remember this is vertical, center, and then we're going to add pickers, which is the horizontal box, display pane, to a vertical box, and message. So the horizontal box objects, which are going to be horizontally spaced, will be added to a vertical box, and then the next thing added to the vertical box will be the message, which is the text. New scene, set the title, primary stage, set the scene, and show. And here is the event handler for the process date choice, local date object, named date, and we get the value, and we set the text of the message to happy plus date dot get day of the week. Color choice, set fill, we call the color picker, and we get a value, and you'll see that work live in just a few seconds. So let's run this. Okay, drag it over into the window. So watch what happens with the color picker. This is the color picker event handler, which displays this palette. Right now I could pick white. It's white, you're not seeing anything. Now red is embedded here. I just can't remember which one it is, but these are all really complex options in the palette. And there you go. And then there's also this custom color. So let's just set it to this blue. And then here is your date picker. Now remember, we're going to pick a date. Let's go back to 2019, 4th of July. And it will return the string of the day. So obviously 4th of July 2019 was a Thursday. 4th of July 2015 was a Saturday. So as always, I hope this was useful, and I will place these files in the timeline in Canvas, but it is critical that you're downloading these, adding them to a Java application, package, class, etc. You know the routine. Thanks for watching. JavaFX nodes, which is another way of saying a graphical user interface control. These control objects generate several types of mouse-based events. And hold on, just stay with me for a second. So the event is in the left column and the description, which I'll go over. So when you press your mouse, it generates a mouse pressed event. When you let go of the button, it generates a mouse released button. When you click the button, in other words, you press down, and it's also called a single click. You get a mouse clicked button. When you move the mouse over top of a node, a control, in other systems that I've coded in, this is called mouse hover, but it's called mouse entered. And then when you move the cursor via the mouse off of a node, there's a mouse exited event. There's also a mouse moved event and mouse dragged. The difference between mouse moved and mouse dragged is moving the mouse and holding the button down, and mouse moved is just moving the cursor via the mouse across the GUI. The mouse event object, which represents the event, can be used to obtain the position of the mouse. And we'll get to that shortly. There are some methods for setting the handler for each type of mouse event, such as the mouse event set on mouse pressed. And obviously, we're leading towards an application that will demonstrate some of these, not all of them. Up until now, the only events that we've been writing event handlers for were action events. Now we're going to see an event handler for a mouse event. And this file obviously is in the timeline for you to download and run. So we're importing a new library, javafx.scene.shape line. And we've also got input.mouseEvent. So let's take a look at how these work together in this cool little application. So we've got a new FX application with click distance class that extends the application to object reference variable 1 to a line named line, 1 to a text named distance text. And here we've got our start method. So we declare a new line object, and it is 0, 0, 0, 0. We'll get to that in a second. And these are Cartesian coordinates. So we've got a new text object, distance text, that starts at 150, 30, and it holds the string distance dash dash. New group named root that we add distance text and line to. New scene, we add root, it's 400 by 300 and it's light yellow. And then we call the event handler process mouse click when the mouse is clicked. All this is old news. So let's look at process mouse click. It receives a parameter that is a mouse event. In this case, it's going to be a click. We have a variable, a double variable, click x, and we call the method getX, which will get the x or horizontal Cartesian coordinate from 0, which is the upper left-hand corner of the window. We'll also get click y with the getY method. Then line set end x, the x coordinate of the end of the line and the y coordinate of the end of the line. We then use a little bit of right triangle math to calculate the hypotenuse of this right triangle. So we're squaring x squared plus y squared. The square root of x squared plus y squared is the hypotenuse. So the square root of x squared plus y squared is the hypotenuse. And that will be our distance. And then string, distance string, and we are going to set up the string, and we are going to display distance plus that value. If I run this, drag the window over to where we can see it. Now, there's our original text object. This is 0, 0. I believe this window was, the stage was 400 by 300. We'll find out. So this would be 400, 0. This would be 0, 300. And this would be 400, 300. So if I click over here, it's going to be something close to 400, 386. If I click down here, it's going to be something close to 300, correct. So when I click here, it calculates the X coordinate. Let me see if I can get right in the middle, which would be 200, 150. So if I could get, well, there's about 200, and this would be somewhere around 150. So right here would be right about the middle. So I hope this was helpful. As always, you're going to have to download these files, take a look at it. Just watching me describe it and not running it and changing the values is going to be challenging for you. When you're moving or dragging the mouse, there's a stream of mouse moved events or mouse dragged events. This essentially allows the program to track the movement in real time. And when we use the mouse to draw a shape, it's called rubber banding. Here we're going to define a line with two event handlers being called from two event handlers for mouse events being called. And this application is called rubber band or rubber lines, and it's very similar to the application we just saw, except we have you use set on mouse pressed, and we call process mouse pressed, the event handler, set on mouse dragged, process mouse drag. Two event handlers that will define, the first one will define the X and Y coordinates of the beginning of the line, and I believe it sets up the parameters of the line. And then the last one, or the second one, will set up the X and Y coordinates of the end of the line. So when the mouse is pressed, current line equals new line, event.getX, event.getY, and set the stroke to cyan, a color.cyan, set the stroke width to 3, and we will call the get children and add the current line to the root. And then when the mouse drag is called, because we're going to click the mouse and then we're going to drag the mouse across the screen, current line set end X, we get X, and Y, get Y. Real simple, very straightforward. I'll run it for you right now and you'll see how this works. Okay. You can see the line is started. I drag it across. And if I do it again, it will call the event handler and start a new line. Pressed, dragged, pressed, dragged, pressed, drag, etc. You know what to do with this file and you know where to get it. Thanks. There are 3 JavaFX events related to the user typing at the keyboard. They are key pressed, meaning a keyboard key is pressed, key released, the keyboard key is released, and then key typed, which means it was pressed and released. The getCode method of the event object returns a code that represents the key that was pressed. This small application demonstrates the use of keyboard event handlers and how we handle a keyboard event. Notice we're importing the key event class library, and so we declare a static integer named jump. It's a constant of 10. This is going to be how far we're going to jump each time a key is struck, and you'll see what I mean by jump. And we're also going to deal with images. So we're going to import image view and image libraries, and you'll see that in a second. So we declare an image view named image view, and a new image object named alien, and this is the first time we're using an external file. I'm giving you this alien.png. It's a graphics file, and all you need to do from Windows Explorer is drag that onto the project in the IDE in NetBeans and drop it, and it'll go in the right place. As long as it's in the project folder, you don't need to specify a path. So we're declaring this image view, and we're adding alien to this, and its original location, I changed this. Let me change it back to 20 and 20. I was just playing around with it before I started this video. Then a new group named root, and we're going to add the image view, which is kind of a display pane type object, to that group. New scene, adding root. It'll be 400 by 400, and the color will be black. And then here comes the event handler for key press. Okay, process key press. Let's take a look at that event handler. Okay, we've got a switch statement. So the keyboard event is received by the method, the event handler method, and then we discover which key was struck with the getCode method. So image view.setY .getY jump if it's up. If the up key, and we could change this to anything, we're going to set the Y minus the jump, which is 10. And so we're going to do that with down, right, and left. And this will all become very obvious as soon as I do this. And if the up, down, left, or right key are not struck, we're doing nothing. That's a default statement. We just break out of the switch. So you'll see exactly what this does in a second when I run this. There's our alien.png. If I press the up key, there it is. There's the down key. So we're jumping by 10 pixels each time. And I'm pressing up, down, left, right, and it just moves it by the jump, left or right, minus or plus, with each key. And if you want to see how this works, we're just mapping this to these keys. I'm pressing the G button now and nothing is happening. That's hitting the default. I could set this to Y. Now you're not going to see this, but I hope that you do this with this. So now if I press the Y key on the keyboard, I'm going up, Down key goes down, left, and the up key does nothing because it's hitting the default. Thanks for watching, and of course you know what to do with this file. Download it, set up the project, play around with it, better understand keyboard events. Dialog box is another GUI control. It's a window that pops up to provide brief interaction with a specific purpose, and the alert class provides support for several basic types of dialog boxes: information, confirmation, warning, or error. And obviously we're going to take a look at these in a short time. Two additional dialog box classes include text input dialog and choice dialog. They prompt the user to enter input using a text field or a drop-down choice box. As we continue exploring JavaFX GUI components, I'll try to make these code demonstrations shorter because a lot of it is review. No new concepts here. We're importing some libraries. In this case, we have text input dialog and alert type need to be in there. If they're not, you'll get a message that they need to be in there. So new JavaFX application, even odd class, extends application. Here's our start, primary stage. We have one variable called do another, which is a Boolean. We set it to true. The whole thing's predicated around a ask before iteration loop. Could also be implemented as a do while, but since we set true, do another as true, we can use a while loop because we want to run this at least once. We declare a new text input dialog box called input dialog. We call the set header text method null, the set title to null. It's not going to have header text or a title. The content text is set by calling this method, and we're going to prompt the user to enter an integer on this dialog box. And then we have this statement here, optional string, num string. It gets a return from the input dialog. The input dialog calls show and wait, which sits there and waits for the user to interact with the dialog. And when it does, okay, if the user enters an integer, okay, it will return num string. However, if the user X's out of it, it will not. So here we have if num string dot is present, if it gets a value, we parse it, or we cast it from a string to an integer. So it's got to be in the form of an integer or you're going to get an exception. And we store that in num, and then we have a string called result. That number is plus num mod 2. If num mod 2 is equivalent to 0, it's even. If not, it's odd. Real simple. Then we have an answer dialog box, and we set the content text, wow, to result, which is that string. That number is even or odd. Okay. Answer dialog, show and wait. Okay, we're waiting for the user to interact in that. And then after they do, we declare a new alert dialog box to confirm, and we get a Boolean, whether it's yes or no. And if it's true, we run it again. If it's false, we just exit. So real straightforward. I'll run this and you'll see how it works. Okay, so here is our Let me scroll up here. Here's our text input dialog box called input dialog. This is it. Okay. And it's going to ask us to enter an integer, and it's going to show and wait. And if it gets a value entered, it will check if it's there. Then it will parse it to an integer. And if that works, we are going to get, so let's do 123. Okay. That number is odd. That is our new alert dialog box. And if I select OK, it's going to then, this is our confirm dialog, confirmation. Do you want to run again? Here we go. Back and forth, back and forth. I can cancel this at any time. Some of the things I'd like you to play around with. You could set the title of one of these boxes to just to show you. And there it is, number. And so let me see what else. Header text. I actually don't remember what this one does. So let's just on the fly see what happens. Okay, yeah. There's our header text. So, like I said, I'd like you to download this code and run it on your own. And have fun with it. And obviously, if you have any questions, don't hesitate to ask me. Let's move forward. Here we look at a project that demonstrates the use of a file chooser dialog box and a text area object. Here's the import libraries we're going to need, some new ones, io.file, io exception, scanner we're going to need, and we're going to need text area and file chooser. The others are ones we've used in the past. So we use the constructor to create a new file chooser object, assign it to file chooser, to chooser, and then file selected file, new file object, chooser, and we call the show open dialog primary stage. This will display the dialog box, a new text area called content, and we set the set the font of the content text area to Courier 12, and it is not editable. It's write protected. Okay, so if selected file is null, no file chosen, else we set up a new scanner object named scan, and instead of scanning system.io or system.in, we scan a text file. Get a string, declared name info, empty, and while scan has next, right? While it has more input to scan, info gets a new line, scan.next line, plus the new line character, which will take us to the next line. Okay, then the text area named content, call the set text method, and we will display info, and then all this other stuff, new scene, new stage, etc. It's pretty straightforward. So let me just show you how this works real quick. I told you I'd be brief as we move forward in this chapter. Here it is. This is our input dialog. I'm sorry, file chooser dialog box. I'll just find some something on my drive. Test output.txt was some output I generated from a file from CSC 121, and there it is. There's the contents of the file being displayed, okay, in this new text area called content. I'm not going to waste any more of your time. We'll finish this up now. You know what you need to do. You need to download this, find a file, make sure it works, and ask me any questions you have before you move forward. The key benefit of a property is property binding. A property can be bound to another property so that when the value of one changes, the other is automatically updated. If you've used Excel, this is very similar to linking the contents of one cell in Excel to the value of another, and the dynamic update that takes place. So there's no event handling if an object is bound to another, if a property is bound to another property. So we're going to look at an example now that binds the center point of a circle and the text of a text object to the size of the scene. And as always, you're going to be able to download these files and run them in your own environment. I'm going to start off by running this application so that you can see the binding in action. And then we'll go back and we'll explain it. So here we have a text object that is, and it has a value here that's bound to the size of this window. We also have a property of this circle, which is the center X, center Y, that is bound to the length and width divided by 2. So it's whatever the length of this window is, this is going to be half X. Notice I'm changing it horizontally, and the circle is staying centered, and this is changing, this property. So there's an example of binding in action. Let's take a look at the code that implements this. So some new imports we have from the javafx.scene.shape. We've got the circle. Let me see what else we have here. Everything else looks like things we've used before. So here we've got a new group, a new scene, and we're adding the group to the scene root. Its initial length and width is going to be 300 by 200, and we're going to set the color at sky blue. Okay, so we're going to declare a new circle object. This will be its, I believe it's radius. It's either, yeah, it's radius. And its name is going to be center. Then we're going to set some properties of center. Okay, circle, I'm sorry, center.centerXproperty.bind scene.widthProperty.divide2. So we're going to take the width property of the scene and divide it by 2, and that will be the center X property of the circle. Center X property, I'm sorry, center Y property, the vertical distance from 0, bind scene.height property divided by 2. So you saw as I dynamically changed the width property of the scene, the window, the center X property of the circle moved. So it was always horizontally and vertically centered in the window. We also are declaring this string property named width, and we're just adding this string literal width space, width colon space, height colon space, and you'll see why we're doing that in a second. Then there's a new text property called width width text 2030 space. Width text property is going to be bound to width concatenated with scene.width property. So whatever the width property is, this text object width text will hold the scene width property. You'll see in a second. Well, you actually already saw it, but so we're doing the same thing with the height. And then root.getChildren, we're add all. We're going to add center, width text, and height text. And the rest of it is setting up the stage. And there's your main. It's pretty straightforward. I'll run it again for you. So center.centerX property is bound to width property divided by 2. So I can tell you right now the width of this is 300. The center of this circle, center X property, is 150. So right now it's going to be almost impossible to get this to, okay, 402 is the width property. I can tell you definitively that this center X property of this circle right now is 201.0. That's the exact center horizontally. And as I change this, so here we have width colon space, right? Width colon space is width, and we are concatenating with the text object, I'm sorry, the string property object, very similar to a text object, concatenate it with scene.width property. So you've got width colon space, and then we're bound to the width property. Hope this is helpful. As always, I'll place these files, or this file, it's a single file, in the timeline, and you know what to do with it. Thanks for watching. A property can have a change listener, which is similar to an event handler. Properties have a method named add listener. And so a change listener method accepts 3 parameters. The property, which is called the observable value, the old value, and the new value. And using this, you can change properties of multiple objects that are defined in the same class. We're going to take a look, obviously, at an example in a minute or two. Here's two examples of coded change listeners, and you'll notice that the type of the old and the new value depend on the type of the value the property holds. So for example, the first listener will change string properties. The second will change integer properties. And as I mentioned, in the next slide in this video, we're going to look at a fully coded solution that changes some number properties. So here we are, and let's take a look at the change listener implemented in this example, which is very similar to the previous example with a circle object in the middle of a scene, and in that particular case we used a binding. In this case we're going to use a listener to change the center of the circle as any of the properties of the scene, the window, change. So here is the change listener. Extends number. You should know number is a parent class of all numeric classes such as long, int, double, float, etc. So they all inherit from the number class. So here we have the type of property, the old value, and the new value. And in this particular, because this is called with the this reference, we can change properties for any of the objects that are declared in this class. So center is a circle object. We're going to set the center scene width divided by scene.getWidth divided by 2, scene.getHeight divided by 2 for the center Y, with text, okay, which is a text object. We're going to set the text to width space plus scene.getWidth, height text, set text, height plus scene.getHeight. I'll run it for you real quick and you'll see it's very similar in the way it functions to the binding example. And it's just a different way of doing things. Thanks for watching, and as you might have imagined, this file will be in the timeline for Canvas, the timeline of Canvas, so that you can download it and run it and see what's going on behind the scenes. Slider is another graphical user interface control available in JavaFX. It allows us to specify a value within a numeric range using a slider. The minimum and maximum value for the slider are set using the constructor for the slider, and sliders can be horizontal sliders or vertical sliders, and there are options for tick marks and labels on the sliders. And obviously we're going to look at a slider in a coded solution very quickly. Sliders have a get value method to obtain the current value of the slider, or you can also use property bindings or a change listener, as we just did in the two previous examples, to react dynamically to the movement of the slider. You could probably see where we're going with this example. So we're going to look at an example that uses two sliders to change the shape of an ellipse object. It's a Java application that demonstrates both a slider, vertical and horizontal, and an ellipse. So you can see we've imported the ellipse from the javafx.scene.shape. Where's our slider? We've also gotten an import for the javafx.scene.control slider. I don't think there's anything. We're going to use a border pane layout in this particular application. So here we declare some object reference variables, an ellipse called ellipse, slider, X slider, Y slider for horizontal and vertical slider. And then we use the constructor ellipse equals new ellipse, 250, 150, 150, 75. Those are dimensions. We'll get to those in a second. And we're going to fill it using the set fill method with color.salmon. X slider, new slider, min, max, and that's the default value of the slider. And you'll see that I'm putting it at the middle of the range. Set show tick marks, true. That will show tick marks. Set padding, new, that's top, left, bottom, right, I believe. But if you're curious, we'll just look at the Java docs because I don't quite. Top, right, bottom, and left is the, so that's top, right, bottom, left. And we're going to bind the radius X property of the ellipse to the slider, X slider value property. And we're going to bind the ellipse radius Y property to the Y slider value property. So as we move the slider, the horizontal slider, you see the horizontal dimension of the ellipse will change because it's bound to that value, and the same with the vertical slider, vertical value. We're going to use a border pane named pane, and we're going to, on the left side border pane, we're going to have a Y slider. The bottom, we're going to have an X slider. In the center, we're going to have an ellipse, and we're going to set the color to gray, and we're going to add the pane to a new scene that will be 500 by 300. The rest looks pretty straightforward. I have some commented out calls to the Y slider, set show tick marks, and set show tick labels. And you'll see the difference. So I'm going to have the tick marks displayed on the X slider, and they're commented out on the Y slider, but we'll show you both ways. If I run this, so you can see the X slider has these tick marks. As we move the slider, the ellipse changes. There's no tick marks here because I don't have them shown. And I also have set show tick labels. So you want to look at the documentation for the slider, and you can see all of the options you have in running the slider or displaying the slider. So here it is. And you see we have labels and tick marks. Once again, I'll put this file in the timeline in Canvas, but you need to download it and explore so you can understand the various options you're dealing with here. Thanks for watching. This application demonstrates. Okay, folks, we're getting to the end of this chapter. I know it was very, very, very long and of significant complexity and detail. So we have two more topics. Tooltips is the first. Tooltip, we've all seen these. When you hover your mouse over a control on a window, There's a little box that pops up with a tooltip. And these are critical components of a well-planned and implemented graphical user interface. I tell people, if you're going to build an application today, it should not need very much documentation, and it should not need, and if it does, the documentation should be built in, but you shouldn't need a lot of training, if any, to run a Windows application. Tooltips, an intuitive graphical user interface, etc., are all part of modern graphical program design. So here's an example of a tooltip assigned using the set tooltip method of a JavaFX control. Use the constructor to create a new tooltip. In this case, the tooltip's string is update cost, and then we simply use the set tooltip method with the object, the control, and the tip. And we're going to see this, obviously, in the last program that we run as a demo in this chapter. At certain states of a program running, there will be times where certain controls may be disabled, and you don't want the user to try to click on them. So a disabled control is grayed out, and I'm sure all of you have seen this in modern Windows applications. So to disable a control, you call the set disable method. Here is a line giving an example of disabling the My Button control. And you could just set it to false at which time you want it to be no longer disabled. This application demonstrates the use of tooltips and also control, the disabled method for control. We have public class light bulb, which extends application, typical JavaFX application. A private button, on button, and off button. So object reference variables for two buttons, and this image view named bulb view. And image view is one of the JavaFX scene image libraries. And I think everything else we've already used. So image, img, new image, and we have this lightbulbs.png, and let me show you what that is. Here it is. It's actually a PNG image that has both an on and off light bulb, and we'll see how that works in a second. This bulb view we call the set viewport method, and to set the viewport we set up a new rectangle 2D, which is in shape. It's a shape in the JavaFX library. It's up here. Yeah, here it is. JavaFX.geometry.rectangle 2D. And these are the coordinates of this rectangle, two-dimensional rectangle. So what we're actually doing is we're going to be moving the viewport, and you're going to see, based upon which button is clicked, the left side of that image or the right side of that image. You'll see in just a second. New button, default is on, set width 70, on button.set tooltip, new tooltip, turn me on. When you hover over this button for, I don't know what the timing is, 2 seconds or so. And then here is the event handler for the button, the on button. And here's the off button, new button, off, width 70, new tooltip, turn me off. This is set at disabled true. Notice there was no disable method called from this button up here because the default is disable false, or set disable false. And here is the, excuse me, here is the event handler for that second button. we're going to use an HBox pane, and we're going to add the on button and the off button. Okay. Vertical box root, and we're going to add the bulb view and then the buttons. Alignment, all this is old hat. So let's look at the event handler. So we get the source, and if this is just a toggle, so we're moving the viewport. So if it's the on button, we're moving the rectangle 143, 0, 125, 200. If it's not the on button, which means it would be the off button, we're moving the rectangle to 0, 0, 125, 200. So the dimensions are the same, but the starting point horizontally is different. And you'll see that in a minute, not even a minute. So let's run this while this is fresh in our mind. So when I click, okay, we're just moving the viewport and displaying it. Okay, so remember what that looked like. Oh, and the tooltip, if I hover over here, turn me off, hover over here. Oh, it actually has to be enabled for me to get the tooltip. So there's turn me on, and if you remember, all we're doing is shifting that rectangle and displaying the viewport of the left side or the right side of the PNG. Hey, we're done. Thanks for watching this video. I know the GUI component of this class is extremely complex and very lengthy, and I appreciate you staying with me on this. As usual, this last application, job application, will be in the timeline for Canvas. Thanks. And of course, if you have any questions, you know how to get a hold of me. Thanks for watching. Have a great day.